So this problem is problem 5 in the web work for section 2.5. It's a biology problem, and we're assuming that initially in a lake the biologists have stocked 300 fish, and the carrying capacity, which is the maximum number of fish that the lake can sustain, is 9,900. The number of fish doubled in the first year, and so we're assuming that the size of the fish population satisfies this differential equation here. And this is a separable differential equation, but you have to do some partial fraction decomposition and integration everything to get the solution. But the solution's in your text in this section, so if you're interested in the derivation of this, you can go through your text. If you have questions, you can email me. But basically, I know what the solution looks like. So I have, from the text here, I have y equals y naught capital K over y naught plus capital K minus y naught e to the minus RT. So this is a little bit different than this equation here, but we just translate this. So my P here is P naught times capital K over P naught plus capital K minus P naught. I have e to the minus little k t here. And we know what? P naught here is 300, and capital K is 9,900. Okay? So we put these in here, and we get that our y here, not y, excuse me, P here is 300 times 9,900 over 300 plus 9,900 minus 300 e to the minus kt. So our P of t here is 300 times 9,900 over 300 plus, what is this, 9,600 e to the minus k t. So this is what we have so far. We can simplify this fraction if we want to. It's not hard. But we want little k. Well, we're given that the population doubles in the first year. So remember, our initial population up here was 300. So when t is 1, I'm going to have p of 1 here is 600, because after 1 year it's doubled. So putting that in here, I'm going to have 600 equals 300 times 9,900 over 300 plus 9,600 e to the minus k, because t is 1. I want to solve this for e to the minus k and then solve it for k. So I just have to do some algebra here to get this for e to the minus k. I'm going to have 600 times 300 plus 9,600 on e to the minus k here equals 300 times 9,900. So I'll divide both sides by 600, and here I'll get 300 over 600 is what, a half times that. So I'm going to get what, 4650, is that right? Let's see, 9,900 divided by 2, 4950. So I get 4950 here. And so I have 9,600 e to the minus k If I subtract 300, I have what? 4650. So e to the minus k is 4650 over 9600. Again, if you like, you can reduce this. But notice I've isolated e to the minus k. And now to get rid of the e here, I take the natural logarithm of both sides. So I get negative k is ln of 4650 over 9600. So k here is negative ln of 4650 over 9600. Went off the page there. So, and this turns out to be about 0.7248958789. So I went out pretty far on here because of web work. I want to go as far as I can really, so it'll take the answer. And putting this back into our original function, then we're going to have our p of t is so p of t here, we're going to have what, 9900 times 300. That was our numerator, remember. And here I have 300 plus 9600 on e to the minus kt, so 0.72485789 t here. So this big fraction there, and I guess I could divide numerator and denominator by what, 300, and get my p of t. So my get some more room here. So my p of t is going to be 9900 over 1 plus 32 e to the minus kt. So I write 0.7248958789 times t. So this is my function here, my population function. And you might notice a couple things. One thing that you can check is that if t is 0 and we do this calculation, I should have p of 0 is 300. I should also get p of 1 is 600. So you can verify those things if you like. You can, if you want, you can verify that p of 0 is 300, and we should get p of 1 is 600. So you can do a partial check on your answer there. Also, you can see that as t goes to infinity, this e to the minus, this fraction times t, goes to 0. And so I get 9900 divided by 1 plus a number that's getting closer and closer to 0. So as time goes to infinity, this function gets closer and closer to the carrying capacity of 9900. Okay, now there's another part to this problem where they want to know is this, is when will our p of t, is on 1/2 of the carrying capacity, 9900. So this is part B here. So now we have to solve this. So we would have, so like I said, part B here, we would say 1/2 times 9900 is our 9900 over our 1 plus 32 e to the minus kt. I know what k is, but I'm not going to write it till the end and put it in there, right? So this means I'm going to have 1 plus 32 e to the minus kt. I cancel those guys out, times 1/2 equals 1. So 1 plus 32 e to the minus kt is 2. Subtract 1 from both sides, 32 e to the minus kt equals 1. So e to the minus kt is 1 over 32. And again, to get rid of the exponential, I take the log of both sides, natural log of both sides. E negative kt is going to be ln of 1 over 32. So t is going to be negative 1 over k ln of 1 over 32, right? Where our k here was this, what was it, 0.7248 958789. So our t here is going to be about 4.78101201. So about 4 3/4 years, we're at the half of the carrying capacity. And that's it for this problem. So I hope it made sense. Thank you.